We begin our journey forward to understand the normal distribution curve. Now, guys, this is one of the most important concepts in this course. You need this concept, and if you get it down, you will be able to move and to rock and to roll. It just takes a little bit of work. It's not that hard, but we can get there. So bear with me, the normal distribution curve. You may remember that I showed you earlier on in the video this picture. And this is a curve, and here is mu, the mean, and on each side is 1, 2, 3 standard deviations, 1, 2, 3 standard deviations. Now, this picture represents the number of data. As we get closer to mu, the number of data that are closer to mu get more and more and more. And the further you get from mu, the less and less they become. That's what this represents. So it's really not that hard. Now let's start out with this simple concept. 100% of the area is under the curve. There's nothing hard with that. The area is balanced on mu. So that means 50% of the curve is on one side, 50% of the data are on the other side. Now, let's think about this a little bit more intently. If we have an average, which is a mean, then 50% are less than the mean and 50% are more than the mean. 50% are below average, 50% are above average. I was in a meeting and many years ago, and a principal in the school I was teaching in said 50% of our students are below average. Well, yeah. And 50% of your students are above average. That's what the term mean implies. This is the numerical average. 50% is here, 50% is here. Now remember that 100% is under the curve. 100% of the area is under the curve with 50% on each side. Now here's a sneaky little change. If 50% is on that side, then 0.5000 is here, and 0.5000 of the area is here, and the entire area under the curve is 1. 100% is under the curve, so that means 100% is 1.0000. 50% is here, that means 0.5000. 50% is here, that means 0.5000. Now what I have just done to you is interchangeably used percent and decimal. And I've just interchangeably said, okay, if 50% is here, 50% is there, and 100% is under the curve, then that means this. And because 100% is 1.00, and we're carrying it out to 4 decimal places, getting ready to meet our table areas, 50% is 0.50 or 0.5000, so we've got this down. Now, in a normal distribution curve, one of the first things that we discover is that 34% of the data lie between the mean, or mu, and 1 standard deviation above the mu. And 34% of the data lie from mu down to 1 standard deviation below the mean. So look at that just a minute. That means that 68% of the data lie between 1 standard deviation below and above the mean. We also discovered that we could say that as 0.6800 of the area lies between 1 standard deviation below the mean and 1 standard deviation above the mean. Pretty clever. Now, if we go to 2 standard deviations above the mean, from 1 standard deviation to 2 standard deviations is 14%, and from 1 standard deviation below to 2 standard deviations below is another 14%. That means that we can convert these into areas under the curve between 2 standard deviations below and 2 standard deviations above. We suddenly notice that we have 96% of the data, with 48% from the mean down to 2 standard deviations below and 48% from the mean to 2 standard deviations above. Notice that I can talk about percents and I can talk about decimals. We have to be able in statistics to interchange these values and to move with speed, and it's really not hard. Now, if 96% of the data lie between 2 standard deviations below the mean and 2 standard deviations above the mean, that means that 4% lie in these areas, which means 2% lies here and 2% lies there. Nothing phenomenal about that. This is called a normal distribution curve. And what it in fact tells us is we get closer to the mean, more and more data appear in this range, and less percent of the data appear in ranges way away from the mean. Now, give me your brain just a minute. If 34.3400 of the area is between mu and 1 standard deviation above the mean, that means that if we have a set of data that are normally distributed, that 34% of those data lie between the mean and 1 standard deviation above the mean. That's a subtle change in what we're saying, but it says the same thing that we identify in this curve. If mu equals 0 and the standard deviation is 1, then what we have is the standard normal distribution curve. We standardize to a curve where we have a mean of 0 and a standard deviation of 1. 50% lie above the mean, 50% lie below the mean. We know that the z-scores on this table are founded on this curve. In other words, notice that here we have 1 standard deviation above, 2 standard deviations above, 3 standard deviations above, 1 standard deviation below, 2 below, and 3 below. These values, when they tell us how many standard deviations we are from the mean, are in fact z-scores. When we use the standard normal distribution curve, what we have done is taken a normal distribution curve and used a special case where the mean is 0 and the standard deviation is 1, because that lets us tell all sorts of marvelous things about the distribution. Statistical analysis is founded on areas under the standard normal distribution curve. This is cool. What you have just done is seen the base of the foundation of what we're going to do in the days ahead. The standard normal distribution curve has a mean of 0, a standard deviation of 1. It allows us to calculate areas between these z-scores, and when we can calculate areas between those z-scores, we can tell how much area is there. We can convert that to a percent, and we may be able to say something like the probability that a random data will fall within the range of this z-score and this z-score is so many percent, based upon our ability to change and find the area under this curve from a point to a point. Now, I told you this was cool. It is powerful, but it's really not very hard. You have just met the Holy Grail, the standard normal distribution curve. The next great thing you will learn is called the central limit theorem. Both of them are easy. They're very neat. But how cool that you've been able to do this. Now let me encourage you to keep climbing the ladder. You've got this. If an old man my age can have 7 root canals, have his gums cut back by laser to get ready to go in a few days and put on caps and still make videos, then let me tell you, even though he's lisping and can't help it, I promise you that you can do this and you can master this material. I have confidence in you. We're going to learn the standard normal distribution curve, and we're going to find how to find areas under that curve so that we can predict probabilities, and then we're going to walk and talk. You're going to enjoy this.